what I quickly came to find is that it's very difficult to go straight. So it really ended up being a line follower, but I guess that's kind of like a preliminary step. So here we have IR sensors on each side. Each one of these includes 3 separate sensors on the board. And what it's doing then is kind of detecting either on the left side or the right side. And it's, so it's using PID, and it's going to...
Do you want to say what PID means?
PID, it stands for proportional integral derivative, although I'm not using integral here. But the point is that what it's doing is making a measurement and comparing the values of each of the 3 on one side. And based off that, it's going to interpret where the line is with respect to these 3 points. So it's going to return a floating point between -1 and 1, where 0 would mean it's directly under the center. And then I figured that we want to at least somehow implement the second sensor, which was kind of a vestige of its original intention. But what we have here then is the track brakes. And the way I end up coding this in is just empirically evaluating what it looks like when the left sensor just passes the tape and goes straight to the floor. So that has a distinct signature where the reading of all 3 sensors on the left side drops. So once that occurs, there's a loop, or there's like an if statement, which then triggers the cart to use the right sensor. Okay. So a little slow, but the point is that, so it's using the left side right now, or it should be, and what it's doing then is it makes the evaluation of a floating point between -1 and 1, and the proportional part is that it's giving a value, whether it says -0.5, that multiplied by a constant then is going to say how much the left motor should speed up and the right motor should slow down. I should mention. So there are 2 little DC motors in here, and they're just both being controlled by the single side which is making the measurement. And they're set so that they balance each other, so that if one speeds up by a certain amount, the other one slows down by that same amount. And the critical part, though, is that, so that's the proportional response, but it's going to store the value that it makes it at like a given time, and it's going to compare it then to the value that it senses that line to be at the next time step. And that's where the derivative comes in, and that then is going to be responsible for, it's also going to be multiplied by another constant, a separate constant, which is going to be much larger than the first one. So its derivative response is going to be much greater than its initial response, or its just proportional response. And that is to ensure that if it is going off track, to correct itself even further. But so it ends up being kind of dynamic here, and the average then is set to half speed, which is kind of determined by the current. But it's kind of difficult, so as I mentioned, both the value that I'm multiplying for the proportional and for the derivative response are just empirical constants from looking at some of the data. But because it's running on batteries, it's 4 AA batteries, it ends up being dependent on like the current battery life. So that's kind of the shortcoming in the project, and that this is based off of some values I was using previously, but as the batteries start to die out, those values kind of need to be updated. But hopefully we make it here soon and you can see it. Any questions?
It's like a freight train heading at you, isn't it? Sorry.
So what sort of time dilation does it experience at these speeds?
Yeah, what is gamma? And so what's going to happen, when will it start reading on the right-hand side?
So originally, because it is based off of the derivative, so it does lose it sometimes. Usually not until the switch. So being that it is based off the derivative, for instance, it seems like it made the switch immediately, or it might be a little confused right now, but let's see what it does here. Okay. So it looks like it did make the switch, but because it is based off of the derivative, sometimes as soon as it gets the right measurement, like the very first measurement, because the prior measurement would have been just based off of what the reflectance is off the tile, it would occasionally cause it